So I'm going to add a new class, and this time I pressed Alt Shift and C. This pops up this it pops up this menu, and then I'm going to call it IElectricity. I'm going to hit the add button. Right, notice that there's the interface keyword. Interfaces, they don't have any access specifier. Some people put accidentally public or private keyword. They don't have to. Probably it's going to give an error, and then we're going to say get electricity, and then because we're going to provide some unit to it, let's return an integer instead of a void. So this is the definition of an interface, IElectricity, and it is going to give us some units of electricity. Now we'll require at least two more things with it. I'm going to create a separate class for this. I'm going to call it electricity. There are different standards, but then you can call it IMPL for implementation or implementer or provider. I'm going to limit myself to provider because it sounds better. Then I'm going to put the equivalent sign, and then I'm going to say IElectricity. If I hit control dot now, it is going to implement the interface, and generally you're going to leave it public. And over here I'm going to say that do the complex part of generating electricity, and then next I'm going to return how many units of electricity was produced. Alright, now we have the interface and we have the provider of it. Alright, it is doing all the complex work and giving us electricity. I'm going to add a new class for the consumer of it. I'm going to say fridge. Now fridge is going to have electricity. It's going to require electricity, and because it is a private variable, one of my convention is I start all the private variable with an interface, with an underscore. So I'm going to say underscore electricity like this, and I'm going to say void turn on the fridge. And for turning on the fridge, we're going to need some electricity, which we already have in this variable. I'm just going to say electricity new electricity provider. Right, and then I would need say units, and then for this unit I'm going to say underscore electricity dot get electricity, and then this unit is going to be is going to get the value 100. Now there are two things that I can show you right now. Productivity tip: if I hit F12, it is going to take me to the interface definition. If I hit control minus, it is going to take me back to the place where I came from, and then if I hit control and F12, it is going to take me to the implementation that is provided. Alright, so I'm back in this function. If I hit control F12, I'm going to go see that function where it is returning 100 units, and then to run the fridge I'm just going to say that consumed, I'm going to say units here, and for this unit to refer to this particular variable here, I'm going to have to put the $sign. Right, let's go ahead and execute this program through the interface demo. Now the interface demo in the run function, I'll require an instance of the fridge itself. So I'm going to say new fridge. Notice the tricky use of var keyword, it is pointing to the class name, and then on the fridge I'm going to say turn on. Now turn on is a private function that we cannot call, so we'll have to modify the access specifier. We'll have to make it public or at least internal, and when we do this, the rest of the wiring is already done. So the interface demo object is going to get created. If I go to the definition of run, it is going to create an instance of the fridge, and it is going to call the turn on implementation, and turn on is going to access the electricity, and it is going to print that it consumed this many energy, and probably we can be be a little productive here. Dropped temperature inside to -2 degrees. Alright, so this is our complex fridge functionality. Let's go ahead, hit Control F5. And there we have it. It consumed 100 units of electricity and it dropped the temperature inside to -2 degrees Celsius. Now, the reason interfaces are so interesting is because you don't always have to. Okay, one pro tip, one advanced tip that I'm giving you ahead of time is that the new keyword is something that you should avoid for classes that you have created. There's something called as hard coding, and hard coding starts with tightly coupling to your custom classes. This is the second instance of hard coding as well. But for now, we're going to focus on the electricity provider. I don't want to use this electricity provider. There is a better electricity provider in my area, and or probably this is power backup. Now, a power backup is also going to provide electricity. So when you want to have different implementations of a provider, you are switching from, say, wind energy to hydraulic energy. That means the way it is going to get represented in the code is that you're going to have a different provider for the same interface. And now if I hit Control dot and hit implement interface, I'm going to get this implementation once again. I can delete this code using power backup at my home, and then it is going to return, say, 30 units. Okay, so we generated some power at our home using the power backup that we have installed. And to consume that, once again, we're going to go to fridge and we're going to change this to the power backup provider. Now if I hit Control F5, we're only generating, say, 30 units of electricity, right? The fridge should not have any intuitive idea about where the power is coming from. And the trick to do that is not to create an instance like this, but create a constructor, and inside the constructor we are going to do something like this. We are going to accept the object of electricity from outside. Make sense? Now, anybody who wants to use fridge, they will have to ensure that the electricity is provided for this particular appliance to work, and we're going to do that work over here. Right now it is complaining. It is saying that it doesn't know where to get this value from. So we're going to come here and we're going to make that decision for the fridge. Electricity assigned to new, and then over here you have both the options. If you want to use the, I don't know where's this coming from. Okay, this is from our delegate demo. I'm going to change this to electricity provider. On the similar lines, I can have a power backup provider. Okay, I'm going to comment this line out. I just want to show you an example that both these options are possible, and then the fridge should have absolutely no clue about it. The fridge shouldn't know where the electricity is coming from, and depending on what the outside application decides for the fridge, it is going to get passed on to the fridge, and then the fridge is just going to consume it. So if I hit Control F5 now, it is going to consume 100 units because it is coming from the electricity provider, and I have an option of switching from one provider to another, and it is going to honor that as well. So the fridge is going to work regardless of the source of the provider, and that is the whole idea of an interface, that it abstracts out, it hides away the implementation detail from the consumers of the implementation. Okay. There are multiple other usages of this thing that you can have. Like if you want to draw some shape, right? All you have to do is create an interface like I draw shape, and then this is going to be an interface, and it is going to have, say, a function like draw. And if I want to support multiple shapes, I'm just going to go ahead and do all the work over here. I'm going to create, say, a class named circle, and it's going to inherit from draw shape. And if I control dot, right, all I have to do is print on the screen drawing circle, and I can provide another implementation which is rectangle, for example, and I print that drawing rectangle. Now the consumer of this is, once again, I'm going to come back to interface demo. I'm going to comment out this code, and the consumer of this is once again going to be unaware of which or um, it can be independent of the object that we are creating on the left hand side, and just say that shape.draw, and depending on whatever instance we assign to it, it is going to go ahead and draw that particular shape. So when you're working on applications where you would want to have flexibility of switching from one source of one way of doing things to another way of doing things, interfaces are interfaces is something that you should consider. And depending on the concrete implementation of these interfaces, you will get flexibility of switching from one way of doing things to another way of doing things. Right? And then with this newfound knowledge, you can do a lot of interesting things. For that, let's go ahead and look at a switch case implementation. Right? Uh, Depending on the user input, we would want to draw different type of shapes. Okay, so I'm going to say input. Let's take that input from the user and call it console.console. I'm going to add the using statement dot read. I'm going to say key, and then if the entered key is, say, R, I'm going to draw a rectangle. Okay. Just 1 second. Okay, because this read key is returning console key info. Right, so this is the character, and then I'm going to put a break statement, and the default control cannot fall out switch. So I'm going to have to put a break keyword as well, and then over here I'm going to say drawing rectangle. Let's repeat this a couple of times. For T for triangle and C for a circle. Right? I am pretty sure that most of you would have already written code like this. That you start with a switch case, a switch statement, and then based on the input, you are going to take different actions and then complete the functionality. When I run this code, okay, sorry. When I hit R here, it is drawing rectangle, and when I hit T here, it is drawing triangle. The only problem with this code is that it is very tightly coupled. It is to add another shape, another implementation to this particular function, you will have to actually come and modify modify this actual switch case statement. This is not a very good way of writing program. Your program should not be very tightly coupled to the implementation expectation from it. So the way we are going to do this is we are going to add an interface, draw shape, and this interface is going to have an implementation called draw. Then depending on what functionalities we want to support, we are going to provide multiple implementations, right? And when we want to make that decision, we are going to take away this capability of picking which object it wants to get created and create this object outside based on these choices, right? And when we have these choices available to us, the right implementation is going to call the correct function, and we will be able to support multiple shapes and features. So let me comment this line out, the switch case statement, and go back to our original example where we had an implementation called iDrawShape, and the shape was taking, okay, right. So it looks like my speaker is not working. Give me, right, sorry about that. So a good replacement for switch case is that you define an interface, and for each activity that you are performing inside the case statement, you go about defining new implementation classes. So if you want to draw a rectangle, triangle, and a circle, you should have 3 separate implementation for circle, rectangle, and let's go ahead and create a third one. Right now, without affecting anything in this application, we can just have this object injected from the outside, and I'm going to say I draw shape. So you can take a shape here. I'm going to call it, I'm just going to rename it to draw. Assign this shape value here, and then just call this function. Okay, this shape I can inject from the outside like so, where circle assigned to a new circle, and if I pass the circle object over here or the circle object over here, in the run function, right, it is going to go ahead and draw that shape for us. Make sense? What we have essentially done is we have gotten away from a code that required constant modification. Every time you want to add support for a new shape, you would want to you will have to come to this code here, right? You will have to come to this code, and you will have to add another case for another switch case statement, right? And it's going to draw that shape for you. But modifying code like this is not recommended, and a good replacement for switch case statement is that you take away the ability of creating instances. You start depending on something more abstract like an interface, and once you start injecting the object from the outside, it is going to make this function permanent. It will not require any modification. The only modification that is going to happen is outside of this function by adding more and more classes. I can support a new shape called X, and then it's going to say drawing X, and all I have to do in the interface or in the actual program, that instead of a circle, I'm going to have to assign it a new instance of x, and I'm going to leave. Let's go and change that as well, right? So without touching the run function, we were able to switch from drawing circles to drawing x's. Makes sense? And now that we have already discussed this concept, this is the strategy design pattern. Right? There are strategy design patterns part of the 23 design patterns. So there are 23 design patterns. Strategy is a behavior pattern. These one in the yellow, they are factory patterns, creational patterns, and then these ones here on the blue, they are structural pattern. So what we have studied is a strategy pattern. You have switched the strategy of drawing shape using the interface, right? So there are more patterns that we're going to discuss. What I wanted to showcase was what interfaces are and how interfaces provide support for different implementation. And through these implementation, you get the flexibility of replacing the switch case statement. So switch case statements and ugly code like this, it can get replaced by something neat, something clean, and it is also extensible. So you get the ability of deciding which object to create at what point and how these objects they get utilized. All right. Collections. So a collection is a group of multiple related objects, right? Uh, there are two ways to collect objects like this. The first is what we have already seen in the previous sessions, which is array, and the second object is you create a collection. The advantage of collection of arrays is that they are easier to declare. Like if you want to declare a collection of integer, all you have to do is use these index properties, use index operator, and over here, if you do integer array like this, you can initialize them right here with a good ease. The way you're going to access these variables is through the index operator, and indexing for arrays. It is not the Wi-Fi. Okay, am I back? Better now? Alright. Something is wrong with my USB ports, and then my headphone kind of gets disconnected every time. I don't know why it's doing that. Anyway, so we were talking about collection. There are two ways of creating collection. A collection is a group of related objects like an array. We declare array using the index operator in front of the data type and define a variable. Now these variables, they can be accessed uh, using index operator. So if I have to access the first spot, I'm going to put value 0. Indexing starts at 0 because it has 5 elements. It's going to go all the way up to 4. So a of 0 through A of 4 is going to give us all these individual objects. The only problem is that collections, they are fixed in number. You cannot add more elements, or you cannot reduce the size. So collection gives you the flexibility of changing that. You have some degree of dynamicity to it, and there are multiple options available to this. So let's go ahead and do a demo of collections. So through this example, we are going to do this, and I'm going to do app.run, and in the collection demo, I'm going to generate a new class. And once that class is generated, I also get an option of generating the function itself. Right, now if I hit F12, I'm going to be taken to the function, and once again it is internal. I'm going to start with a variable, and I'm going to call it students. I'm going to use a new type that we have not introduced so far. I'm going to call it new list, and over here we're going to use generics, and using generics we're going to pass it a type of string like so, and then now it is giving us a red squiggly, and if you read the L message, it is saying that the namespace is missing. So let's just control dot, and it is asking us to add a using statement, system.collection.generics. If I go to reference and expand, you're going to see that that namespace is not present over here. But let's go ahead and hit control dot and add the using statement. And this using statement is going to, that operation is going to add this piece of code for us over here. And now the error is resolved. I'm going to add students.add, and I'm going to start with my name. I'm going to add some dummy students, and then I'm going to do a for each. I'm going to say for each student in the collection students, and then come here and print use this variable student. So what I've done is I've used a built-in class called list. I've told it that what I'm storing inside it is a series of strings, and then I went ahead and added these three variables. When I used a for each statement, I used this variable which was type list of string, and I have added a for each statement. This for each statement is going to give me access to each member one at a time, and it's going to put it in this student variable. And if I print it, then it is going to give me this output. Right? Arrays would have been very similar. So if I declare, say, so I'll have to declare it like this: string array x, and then new string array. And if I want to do some hardcode initialization, I can do that here in line, like A, B, C, and then X. I could write the same program. Let me comment out this piece here and put another for each statement. I'm going to say for each item in X, print the item value. Now if I hit Control F5, right, it is going to print those 4 values for us. But I won't have the flexibility of adding other elements to it. Right? The only way I can add is I can use the index operator, and using the index operator, I will assign, say, a new value to this. Right? But then, because this index is already falling outside the count, index 0, 1, 2, 3, fourth element is not present. So this is going to give an exception. So arrays have a restriction that they won't, I can show it to you. It is going to give an exception, index out of range exception. Index was outside the bounds of the array. The array bounds, they are 0 to 3, and we are using number 4. Number 4 is not available. So with arrays, you will have to know the size that you would want to store inside them upfront. And it is not always the best use. If you are using only like two members, these two memory location or whatever you declare extra, they're going to get wasted. You don't always have to initialize an array. If you want, you can leave them uninitialized like this. And if you already know how many elements you have, you can mention that number over here. Let's go ahead and create an array this way and assign value only to the fourth spot. And in the for loop, we are going to try to print the value. If I hit Control F5, notice that it printed a series of empty spots. Then on the fourth spot, it printed Z, and then another 6 empty spots followed by that. Alright, so the array members, they all were initialized with a default string. I think they were not, they were all null. And then on the fourth spot, we had a specific value. But then once again, the concept is that you will have to know the size upfront, and you are limited to that particular number of elements. The advantage of arrays is that they are a little faster because they don't have any extra frills. So the memory representation for these arrays, it is going to look a little better. Let's go ahead and comment this. We're going to discuss this once again on the whiteboard. Right? So arrays, when they are declared in memory, right, they're going to find excuse me. Right, arrays, because we know that this is a fixed string type, the memory location that will be given to these variables, they are going to be contiguous. Because it is string is a reference type, it is going to store reference. But then these 10 variables themselves, they are going to be contiguous in nature. They're going to start with index 0, they're going to go all the way up to index number 9. And the memory locations are kind of sitting together. With list, it is going to be a little different. Lists themselves, they have a tricky internal implementation. Depending on what parameter you pass over here, they are going to give you different sizes. And every time you cross that size, it is going to double up in size. So the next batch that it gives you, it is literally going to double up the size. So suppose you created a list for storing 10 elements. You add the 11th element to it, and it is going to give you 20 elements. You are not going to see it because the internal list implementation is going to abstract out, hide away those implementation details as to how many elements are present inside it. But they have the flexibility of dynamically increasing and decreasing the element size. Now, we already saw, how this thing is adding multiple elements to the collection. So lists are better way of storing information. They are more memory efficient, and at some point you're going to realize that having a fixed number only makes sense when you know that this number is not going to increase or decrease. There's no degree of dynamicity to it. But then when you don't know how many elements you're going to store, and that number can keep on increasing, you can go ahead and you should go ahead and start using data structure like this. Another advantage of using built-in collection classes like list is that there are multiple implementations of these collections that are present. So a list is an ordered collection. All the elements, they are going to get started at the index 0, and then they're going to work forward. But you might have different requirement for different type of storage. One type of storage that you would come across is a stack. So in a stack, the elements that go in the first in, they would be the last ones that are coming out. First in, and it is going to be last out. So the element that goes in first, it comes out last, and you can go on inserting multiple elements to it. And with arrays, you are not going to have that kind of flexibility, right? And to the base class library has these different collection classes available to us from the outside, from the base class library itself. So one such implementation is a stack. Now with a stack, you are not going to get the add function. You're going to get something like push. Right? When you say push, it is like actually inserting a value into the stack. If you do 3 push, right, it is going to insert 3 separate values, and then the way to read from the stack, we will probably not be able to have a for each statement, but then you will have to run a series of pop statements, right? And then if you are injecting x, y, and z, the pop statement is going to take out value z. Now in scenarios where there will be scenarios in the code that you're writing where you will require this functionality, that you would want to process the last information that came in and and perform some operation on that. So push and pop is going to give you that flexibility of how you want to save your collection and how you want to extract out values from those collection. There are other implementation of data structure as well. The other data structures are, say, queue. A queue is a little different than the stack. So queues are going to have the model of first in and first out. So when you insert an element into the queue, the first element is going to sit here, the second is going to sit here, and the coming elements they are going to get injected at the back of the queue. So queue is another data structure, and if I can pull up some more, there's something called as a dictionary. Now, a dictionary is also a collection, but then it is a combination of two separate values. And then you have the flexibility of defining the data type here. So you can have a dictionary of string and string, and then you can store values inside it. So C# can have this value here as a high level programming language. Right? So if you want to have key value kind of storage where a key is going to indicate a certain value, you can use a dictionary. Then there is something called as a hash set. A hash is also similar to a dictionary. It is going to have, once again, key value storage, but then this hash is going to be unique. And when when you want to store information and divide information according to different partition size, or you want to provide some mechanism of doing fast retrieval, you're going to generate this hash key, and then based on this hash key, you're going to extract out the information present over here. So this is another type of collection. Then there are a combination of these collection classes. So like list and stack and queues and dictionary, you have at least 2 more implementation. One is a sorted list. So every time you inject a value into this list or insert a value into this, it is going to get sorted by some rule, and values are going to get injected. So it had 1 and 4. If you insert a new value, add a new value to it, it is going to find a spot between these two. And then this functionality is also available with the dictionary class. So with dictionary, you also get something called as sorted dictionary. Right? A sorted dictionary is similar to a dictionary, but then the data inside it is going to be sorted. So let's go ahead and see example of some of these. So we are in the collection demo. I'm going to comment out this function. Once again, I'm going to type internal void run. And over here, I'm going to declare a type called bar stack. And instead of a list, this time I'm going to create an object of a stack and declare once again. Say we can change the data type. This time create an integer stack, and the two operations that are available to you through stack are push and pop and peek. Right. So let's go ahead and push a couple of numbers on this. We're going to start with 50. And we're going to stack.push, and we're going to stack 40, and then we're going to do 30, 20, and 10. Now the two operations are pop. Notice that pop is not taking any variable because you cannot, not taking any value because you cannot control that, and it is returning an integer. So I'll have to check the value over here like this, and if I now print this value, what we're going to get is probably 10. Alright, so what 10 here, and a series of pops is going to uh, give us different values. So if I pop 2 times like this and hit Ctrl F5, this time uh, we have lost the value 10 and we got 20. Right, we can observe other variables, so let's just go ahead and put a breakpoint here, hit at 5, and the control has reached here. Let's go ahead and add it to our watch list, and notice that there is a property called the count. So every time we execute a pop statement, the size of this array here is going to disappear, is going to reduce, and the element at the 0th index is always going to be taken out, and the data structure is going to get modified. If you want to execute something like this in the Visual Studio itself, the option is the immediate window. So let's go ahead and open that. If I type immediate here in the search box above and select this, it is going to pop open this window. Now I can do stack.pop, and if I hit enter, it is going to print the value 30. And now if we go to the watch window, we're going to see that there are only 2 members in this particular stack. Right, so all the properties that get modified in the watch window, they all turn red. Okay, so stack has multiple push and pop options. Once again, I'm going to end the code here, and let me take you inside the implementation of this. So if I hit F12, you see that stack is a class with one generic type of T, and it is implementing. Alright, it is not inheriting, it is implementing through multiple interfaces: IEnumerable, ICollection, and IRead-only collection. Right? And then if you look at the public properties, right, one thing that when you see something like this from metadata, what it is actually doing is it is going to the global assembly cache, and it is extracting, it is picking up the DLL, and from the DLL it is only showing the public, excuse me, it is only showing the public members of the class of from this assembly. So class itself is public. Right. So class itself is public, and it has members like integer, clear, contains, copy to. There's something called as getEnumerator. It is coming from IEnumerable class. We're going to talk about that. Then the peek function is returning t. The pop function is returning t. There is an option of converting it to an array, and there is something called as enumerator. Every class that has this enumerator and this implementation they provide the option of they provide the option of using this data structure in the for each class. Right, so let's go ahead and in our collection demo, once again, put a for loop or for each loop for each item in the stack. I want to run the collection. Right. Now if I hit Control F5, because we have already extracted two values, let me go ahead and comment this section out. Now if I hit Control F5, it is going to give me all the values, and notice that the order is kind of flipped. We started with 50 and then inserted all these values or pushed all these values in the stack, but then when we ran the for loop, it is giving us 10, 20, 30, 40 and 50. And we are able to see all these values. But the real usage of a stack is when you want to push values and pop values, right? So even though you have an option of for each available, you don't have to use this. If you just want to iterate over a collection without doing push and pop, stack is not your go-to collection list. If you just want to iterate through item, you should fall back to something like list, right? So this is stack. Let's go ahead, copy this code. I'm going to comment this section out, and let's do queues over here. So if I type queue, I've modified the variable name, but then once again notice that there's this little bulb that's lit. If I hit Control dot, it will give me an option of renaming the stack to the queue, uh, the variable name from stack to queue, and then it has only gone ahead and done it for the code. It has not done it in the comment section, so it's not going to touch comments. I'm going to change this type from stack to queue as well, and then inside queue you're going to have different values, different methods. So let's go ahead and look at what those methods are. So I have hit F12 again on this definition. There is something called as once again queue is inheriting from multiple classes, multiple interfaces, the IEnumerable of T, ICollection. And then because it is implementing IEnumerable and it has this enumerator constructor, we will be able to use it inside the for loop as well, inside the for each loop. But we don't want to do that. A queue gives you two options. One is enqueue. Enqueue is going to take an item of the generic type, and dequeue is going to return you object of that generic type. Okay, once again, it has an option of count, so you would know how many elements are available inside the queue. So you enqueue and dequeue in a queue. This way you will be able to implement functionalities like this, that the elements that came in first, they are added to the queue, and those who are coming last, they are getting injected, they are getting inserted at the back of the queue. So you would have some form of processing, like better processing it in order. And the implementation once again is going to be fairly straightforward. If I go to collection demo again, I'm not going to get an option of push, I'm going to get an option of enqueue. So if I enqueue these values 10, 20 and 30, this time let's go ahead and replace the for each with a while loop, and with this while I'm going to say that when the count is not equal to 0, let's just dequeue the result. So I'm going to say item assigned to queue dot dequeue. Dequeue is going to take the first element that got added, and we're simply going to print it on the screen. Right? So it is the same order in which the items were added, and the count every time dropped all the way to 0, and we were able to process this queue in this specific order. Let's see an example of a sorted list. So notice the nice IntelliSense here. It is giving us three options: dictionary, list, and set. We're going to use a list. For sorted list, I'll have to add Why is it doing that? So it's a new sorted list. And probably it is going to take. So it is taking two parameters. The key itself, I'm going to give it integer, and this is an integer as well. And then let's change this name to sorted list. I'm going to control dot, rename the variable from queue to sorted list. And with that done, let's get rid of this commented code. I'm simply going to say sorted list dot add, and the add function itself is going to take two parameters. So the key, it is based on the key that this value is going to get selected and the value that I want to insert. So let's go ahead and inject a couple of values. I'm going to say 5, and then 10, and then 20, and 30. And then each time I'm going to give it a different value, like 5, and 2, and 10. It is based on this key here that the index of the elements 5, 10, 20, 30 is going to get decided. We can use a while loop, but then while makes more sense when you don't have any, when you have a condition against which you want to run the loop. Because we want to run it in this exact specific order, we should fall back to using for each. And now if I do console.writeLine and item and print the result, okay, it is just giving us in this format, but sorted list dot values. And now if I hit control F5, the order is kind of flipped. 5, 20, 10, 30. Right, so there's something called as, so let's look at the implementation or the members available to us in the sorted list. So sorted list is going to give us values, and I was hoping that we are going to get another collection which is going to give us values in the order in which we were expecting it. Right. So it had a member called get by index. So let's go ahead and read this documentation. It presents a collection of key and value pair that are sorted by key based on the associated comparer implementation. Because our key is an integer, this code should have compared these values, and it should have injected values a little differently. So the key itself, right, I am give me some time, let me fix this, and let's jump to our last implementation for today, which is a dictionary. We call this dictionary. A dictionary is a mapping between two types. So up until now we were seeing like one generic parameter. Dictionary is going to take two parameters. The first is the key itself, and the second is the value. Now if we go ahead and call it an instance of dictionary like this, once again we have option of adding value to a dictionary. The first value of, okay, because we are using both string, it is going to appear here as string. I'm going to call it C#, and the value is object-oriented programming language. And then if I say C here, it is going to say structured programming language. And then let's add a third example called Lisp. Lisp is a functional programming language. Now The way to iterate through a dictionary is exactly the same, that you come here and then you mention dictionary, and then each item is, instead of just one element, it is going to give you two elements. It is item dot key, and it is going to give you item dot value. So when we do this, it prints keys and values. The key was the first column, the first member. The value is the second member. But a dictionary can also be looked up, something like this, and then you can pass it. You can pass the index, the value of these keys inside this particular member, and it is going to return you the value that is stored against this. So you can directly jump from one element to any element, as long as you have the key for that particular element. So if I select dictionary and switch this to Lisp and hit Control F5, right? Because there was a typo, it is going to bring the value for that particular key. Now, the way you're going to use this dictionary is when you have some unstructured data and you have figured out the way how you would want to store, how you would want to generate these keys which are unique for the element. You can jump from one element to another. Also, these need not always be string. You can switch from string to uh, integers and then pass it 1, 10, and say 5 for this one. And once again, to retrieve the functional programming language, I'm going to pass dictionary value of 5. If I hit Control F5, it is going to give us the value at that particular key. So the key was 5, it was an integer, it returned us a value of a string. Once again, we are not restricted to built-in data types. We can have our own classes like customer, and I think I'm declaring it at the wrong spot. So this class already exists. I'm going to say employee, and then this could as well give you that particular employee value. Just that when you are creating this dictionary, then you will have to provide the correct data type. So I'm going to comment this out and delete these two lines, and probably change this to new employee like this, and it is going to inject the first. It is going to add an employee with this at this particular key. Right? So it is possible to use custom classes as well, and then map it to anything that you want. You can map a string to an employee, and you will have to pass some employee ID here. And probably this is not going to work because it will require, once again, a string value. So these are some of the built-in collection classes. Let's take a quick break. When we come back, we are going to look at how these implementation classes, how these collection classes, they are implemented, and the three separate interfaces. So a quick 10-minute break. We're going to connect back again at 9:30. Thank you, guys. All right, I'm sorry about that. So what we have done is we have created a new class, interface of collection, and we are going to see the three interfaces that make all of this possible. I have declared a new variable of type list of integers and have pressed F12 on it. And there are three distinct interfaces that I'm seeing over here. One is IEnumerable, one is ICollection, and the third is IList. Now, if I have to draw a chain of an inheritance chain, or okay, I don't know if I can call it inheritance. Interesting. So there are three interfaces that we saw. One is IEnumerable, the second is ICollection, and the third is IList. When you are working on collections, of object, you will always come across all these three options. Um, An enumerable is like the name, the dictionary meaning enumeration. It is going to give you the ability of traversing through the list of elements. All right. So in a collection of objects like this, because of IEnumerable, you will be able to move from one element to the second, to the third, to the fourth. Right. This is this is required if you want to put anything in the for each loop. Okay, it is going to give you multiple implementation. I'm forgetting the function name, but we're going to look at real quick when we go to the implementation. I think it is going to give you a function called get enumerator, and this is going to be a separate interface object itself. Using IEnumerable, you will never be able to inject. Let me use a different color. You will never be able to inject a value in in a collection. So injection is not allowed. But then one of the functionalities that we saw was .add. Um, the counterpart of this is .remove, and these options, they are available in the ICollection class. So if you want to have a collection where you can add and remove elements, you would want to use the collection classes. So after these 6 elements, if you want seventh element, or if you want to delete a couple of elements from this collection, you will have to use the ICollection implementation. IList is a combination of these two. Okay, because we would want to iterate through this collection as well. We are going to, I am confused about the word that I should use. We are going to inherit ICollection from IEnumerable. But then I am really skeptical about the word that I've used. I don't know if it is inheritance between interfaces or it is extension, because extension is going to be the provider of this particular thing. So I think this is interface inheritance, that you have inherited the ICollection interface from the IEnumerable interface. Enumerable, it is, alright. And then because of this inheritance, you are going to get the ability of iterating or putting it in the for each loop, an ICollection object as well. The IList is inherited from ICollection and IEnumerable both. So it is going to get both all the members from these two collections. It is going to get the enumerator, using which you can move in a collection, and it is also going to get the ability of add and remove. The only extra functionality that IList is going to give you is the index operator. Now, now index operator is a little interesting. These two implementations, they are going to give you a serial way of accessing members in the collection. But then the index operator will help you jump to a random element. So depending on what value you pass here, right, you can jump from one element to another element without looping through it. So you don't have to write a for each or a while loop and then wait for that element to come or that index to come. You can provide that index right away inside the index operator. So this is my favorite interview question, where I ask people that you've used collection classes. So IEnumerable, ICollection, and list. Please see, how do you decide when to use which collection? And the answer that I expect is that enumerable is when you have a collection ready and you just want to iterate through each of these elements and access the value and perform some operation, some decision based on that. A collection is when you want the ability of adding and removing, and a list is when you want the ability of jumping from one element to another. With that said, if I draw back our memory structure once again, when we declare an object, it is going to have two phases to it. So suppose I declare an object of IList and assign it XList and declare it using IList of integer, right? This variable itself, x of list, is going to get declared on the stack, right? And it is going to point to a memory location that is sitting somewhere else, to be precise. in the data segment here like this, and there will be a reference to that particular memory. All the members that we add dynamically, they are going to get added here. Probably they could be scattered across the entire data segment depending on where the memory is getting available. Uh, when we write code, so suppose that we have a function which is returning us students. Because it is plural, I expect some form of collection to go here. That collection could be IEnumerable, could be ICollection, and IList. So the second answers that I expect for the question when to use enumerable, collection, and list is this, that on the left side of anything, 99% of the cases you would want to return IEnumerable, because this get student function might have gone to the database. Number one, it has processed the query output and it had generated a list already. So those 100 students that we have, they are already present in the list format over here. Now the question is, do you want the recipient of this particular, of the caller of this function, do you want to give them an ability of injecting student number 101 in this particular collection? If your answer is no, and in 90% of the cases it will be no, then you should return enumerable. Alright, because an enumerable is going to take away the ability of injecting any more element to it. So it should not be a collection, it should not be a list. Definitely. Right? Not a collection, not a list. It should always be an enumerable. Because you have processed the data, you have generated the data for somebody, and you don't want to give them the ability of modifying. Alright, and this is where knowledge of interfaces becomes so important, that the way we had the eye draw shape, we are restricting the functionalities that the recipient of this data can do on that particular object. We don't want them to modify. If they want to modify, they have an option of generating a list at their end using this particular member. Right? The reason I showed you this RAM diagram is because when you return a list, it is not this collection that you are returning to them. Right? It is this. It is a copy of this address that you are returning. So if I return a list over here, essentially there is going to be a new element, and this new element is going to have the same exact green reference, and it is going to point to this particular list. And now if they modify, if they add a value, our get student function is going to get affected, right? So the information that we have generated by connecting to database, that information is not reliable anymore, because outside functions which are outside the control of this particular function here, they can influence what values are present inside this particular list. So depending on what operation you would want to allow the recipient, you would want to return a specific object, right? A very tricky situation. Simple rule is the left hand side of any function should be IEnumerable in 90% of the cases. And the way to create a new list using an IEnumerable is as simple as calling a function called .toList. But then this function is a performance hit. I have seen applications where .toList is done randomly. People are like taking an enumerable, converting it to list, and then their application slowed down by a good 12%. All I did, I reviewed their code and I asked them to remove .toList, and their application performance had bumped up. Right? There are very specific scenarios that you would want to call this function. And once a scenario is a very close member of this particular family, IEnumerable, ICollection, list, and it is called as IQueryable. Right? When we study ADO.NET or Entity Framework Core, we are going to look at IQueryable very closely, but then IQueryable is a close cousin of these three interfaces. And then even with IQueryable, all you're going to do is you're going to generate a series of Lambda expression that we saw last couple of days. And this series of Lambda expression, they are going to get saved inside this particular value. And the way to execute this or call all these functions is by calling this function here, .toList. So as soon as you do this, all the Lambda addition or the delegate that we have passed here, they are going to get added, they're going to get saved, and on calling to list, it is going to get executed. More on this in the coming sessions. So we saw this. Now let's jump back to all these three interfaces and look at them more closely. So if I'm going to hit F12, and then the function name, as I correctly recollected, it is getEnumerator, but it has only one functionality. And if you read through the documentation, it is going to set returns an enumerator that iterates through a collection. If you want to run a for loop, you will require IEnumerable. Right, I'm going to hit this back button. I can also hit Control minus. And next, I'm going to go to IEnumerable of t. Now, IEnumerable of t, it takes an out parameter of this, so you can return the parent and the child both from the enumerator, and it is extending this function. Right? When an interface overrides something like this, there will be two enumerator functions that you're going to get if you inherit from this. I'm going to show more of that later. But this interface is supporting all the interfaces, all the functions that are present in IEnumerable, and it is adding more to it. So it is like inheritance, like parent had I, J, and K, and child had X, Y, and Z. So the new effect is going to be list of all the members. So after this, we're going to get two methods for this interface. ICollection is also present in two variants. One is generic, one is non-generic. If I hit on the non-generic, I'm going to get the count property. I think we saw during the stack example. Then nothing much, right? There's a copy to functionality, asynchronized sync root. It is used for some other places that I'm not familiar. Gets a value indicating whether access to the collection is synchronized, thread safe. All right. So this is going to get used for implementing thread safety. Thread safety is something we're going to see next week. So I'm going to close out, and I'm going to go to ICollection of t. If I hit F12, notice the add and the remove functions over here, and a clear function. So add is going to add one element, remove is going to remove one element, and clear is going to empty out the entire collection. It does not once again have any iteration, but then notice the inheritance hierarchy here. So it is inheriting from IEnumerable and IEnumerable of t. Okay, through these two functions, we are going to get enumerator from here and get enumerator of t from this function. Okay, let's look at the last batch, and the last batch is IList of t. For some reason, I have so there is an IList of t non-generic. If you look at this one, it is inheriting from ICollection and IEnumerable, and it is providing an index operator. So an index operator is going to give you the ability of jumping to a selected specified index. Makes sense? Let's look at the generic IList of t. And generic IList of t is inheriting from ICollection, IEnumerable, and IEnumerable, and it is giving you the ability of index of and the index operator itself. And it has two more functions, insert and remove at. Right? So with this, a class named list is created. Now, you might have seen that ICollection itself is getting inherited from IEnumerable, IList is getting inherited from IEnumerable, and IEnumerable itself is going to provide you the getEnumerator function. When you see multiple extension chain like this, all these functions, they get inherited, or I'm so sorry, all these functions, all these methods from these interfaces, they are going to get added to the list function. Only one implementation is going to be public, which is getEnumerator. All the other implementation, they are going to be private. All right, and that is the private implementation of those interfaces. But if you look at the implementation detail of the list class, you are going to find not one, but three implementation of getEnumerator. Right, and there is a mechanism of appending the name of the interface itself in front of this. So it's going to be IEnumerable.getEnumerator, ICollection.getEnumerator, and IList.getEnumerator. And through this, we'll be able to provide different bodies for the getEnumerator, and all those bodies, they're going to call this one public implementation. So regardless of what interface you are using, it is always going to call that single implementation. Difficult concept, but but I just want to introduce it to you that it is possible to inherit from multiple interfaces at the same time and override the function names. right? So that brings to the end of list discussion. Let's go ahead and create a new list of integer over here and assign like a couple of values to this. Right? There's a special syntax using which uh, you can select different values from this thing, and then if I want to select only odd numbers from this particular list, there is a special syntax for selecting this. If you followed through the link, the database lectures, the syntax is a lot like a SQL query. I'm going to start with the from keyword. I'm going to select from this list over here on line 13. Give me 1 second, I got a little confused. Alright, this is not list. I will have to give the item that I want to select. So from item in the list, like this, I'm going to select the item itself. Now, what the syntax is saying, that there's a collection named list. Go ahead and start iterating that collection and take an individual item and put it in this particular variable, and then we are going to use that variable using the select word, and all those variables, they're going to get assigned in the odd collection. So if I hover over odd now, it is going to be list of integer again. Right. So it is not a list of integer, it is an enumerable of integer. Okay. Because it is an variable, I can put it inside, not odd, I'm going to put odd here. And if I do console.writeline.x, let's go ahead and wire up this code here. Comment this out. I'm going to control F5 and I'm hoping that it is going to print 1, 2, 3, 4, 5. Okay, let's go back. My intention through this loop was to identify all the odd members. So the way we have a where clause in SQL, we have a where keyword in the LinkU expression. And over here, I can give it a filter that if the mod 2 of the item is equal to 1, then it is an odd number, so only select odd elements. Now if I hit Control F5, it is only giving me odd elements. Make sense? So LinkU is a language integrated query. It is SQL query-like syntax inside a C# program, and it works on a collection, and using the from, where, and select keywords, it is going to give you a different projection of the collection. Now, to write this kind of program using the regular C syntax, we would have written a code like this, that there's an integer variable I, there's a count. For each count, I would want to get an element assigned to list of I, and then I can, if I do this, integer mod of the element mod of 2 equal to 1, and I can print the element here. This code is going to print all the values that are odd from this particular collection, but then it is not giving a projection of the data. So what LinkU is going to do for you is LinkU will take a collection of data 1, 2, 3, 4, 5, and it is going to give you a new copy with only odd elements 1, 3, and 5. Right? This was list and this is odd elements. So when you want to create a projection like this, LinkU become extremely effective because of the syntax. If I had to write for each and the native code, the traditional code, I would have to create another variable here, list of integer, call it odd list, assign it to a new list like this, and probably inject one value at a time instead of printing odd list dot add and add element to it. Now this is very wordy. There's a lot of there are a lot of C# building block constructs, control flow statements that are getting in picture. But then this syntax here is pretty concise, and it is giving a very good idea of where we are reading the value from, what are the filter criteria, and how to generate a new value. Now you can get very creative with the syntax. There are multiple options available. You can select this. I think I can order by over here, and if we had say some random order of numbers, I'm going to comment out this piece of code here, and order by, I'm going to say item, and I'm going to select the item itself. Now it is going to select the odd elements. It is also going to order it, and we are going to get our sorted result over here. So it is 1 1 3 5 13. I don't know if it is correct. I'm going to believe that it is correct. There are 2 ones. Okay, so I was going to put a 10 here. Okay, so it is going to give us a sorted result in the same time. I mean, imagine you had to sort as well this collection, right? LinkU is going to make writing such projections. The reason I'm calling it projection is because it is taking this input and it is projecting it into this output over here. So LinkU is going to do this work for you, and then it has option of so if you're not comfortable with the syntax, you can also chain it using another way of writing a LinkU query. So you start, I'm going to call it even numbers this time. I'm going to say list dot where, and inside where I would want to give a condition for even numbers. But then if you remember our syntax uh, from the delegate lecture, I can use a delegate over here. In a regular world, I would have written a function which will return a bool is even, and it takes an integer x and it returns x mod 2 equal to 0, right? I'm going to call it. I can pass that function over here like this, and I might have to pass x. Okay, very difficult, right, of calling this function inside the syntax. An easy way is that you define this function in line here. So this integer variable is going to come and get assigned to this value, and then this condition over here, because it is only single line, it can go without the curly braces and the return part. And I'm going to type select, and inside select I can use a different variable, right? And once again, this is very similar to this syntax over here, just that it is taking all the even numbers. And if I run this, it's going to get me all the even numbers. Now surprisingly, they are already sorted, so let's inject an even number in the beginning, and they are coming. They are not sorted yet. It was because of the input that it appeared sorted. I can go ahead and I can add the order by clause, and inside the order by I can use a new variable, and it is going to sort it using the value z here. If I run the program now, it is going to sort it based on the input value. So what is essentially happening, let me copy the syntax of this line of code. Let's go to whiteboard. So each part of this expression is getting executed a little differently. So let's look at the where part first. The where part is going to take and it is going to iterate through this collection, and it is going to generate a new collection with after the end of execution of this particular function. Now the where clause is going to look like, the output of this where clause is going to be all the odd numbers in the list, all the even numbers in the list, right? When we put another dot and call the order by function, it is going to sort this collection, and it's going to say 4 10 12 and 20. and it is this output that is getting passed to the select statement. Select statement is simply iterating this value, and it is generating a new collection with it. So in the beginning we had a list. After the where clause, we got a new temporary list, and then if you remember our syntax of anonymous object, there's a tick and there's a name A, and it is going to be a collection of integers. After the where, the output that we're going to receive is an entirely new enumeration with these values. So I can put a B here with the index operators, and then after the order by, the order is going to switch, and after the select we are going to get yet another collection, and this collection is going to have these values. Now just to illustrate our point, I'm going to change our select statement from select y into select y into y. Now what it is going to do, it is going to take the input, this collection over here, which was sorted 4, 10, 12 and 20, and it is going to do square of it, and it is going to return that value. So let's see if it matches our theory. So every time we pass on, we process the value, we are not affecting the same collection of list over here. Let's go ahead and duplicate this for each loop for the list, and just to have a distinction, let's put some demarcation. Right, the original list is not affected. Right, it is the same list with all the values that are there. With those multiple projection statement, we are taking this list, we are converting it into a new list with the filter criteria or whatever operation we wanted to perform. And when we are done performing that operation, we are picking up the new collection and we are passing it to the new function in the chain. So we took the initial value, we created a new set, we passed it to order by, we processed it, we sorted it, and we passed it on to the next consumer in the chain. Right, and with select, it kind of ended there. There are multiple other operations that are available inside LinkU. One of them is join. So this is more like a join query from SQL. There is another clause called having, I guess. LinkU has order by having. There is a group by clause as well. Group by a two-letter or a group. There's an option of grouping as well. Okay, so depending on what kind of list you are creating, LinkU is going to give you a lot of abilities of processing the data right here in line. And if you're not compatible with the syntax, you can always fall back to chaining these function calls. So I'm going to quickly press F12 on where, and then let's see the definition of this, what this where function looks like. Right, and this definition is a little different. Let's start with the definition of the class itself. This sits in a static class called IEnumerable. Right, and look at all these functions. All these functions in the static class, they are also static. Right, and we were looking at the where function. The where function, the first parameter that it takes is this variable. The second is IEnumerable of source, and then the next function is a func itself. Now if you remember our discussion, this func is going to take two parameters and it is going to return a boolean. The other implementation is that it is going to take one parameter and it is going to return another boolean variable. So I think we were using the second implementation. When you see this keyword here on a static function inside a static class, these functions are called as static function extensions. When we declare a class has only those members inside it, so the program class only has a main function inside it. If you want to add extra function to a class which you have not created, you can use that syntax. The syntax itself is going to start inside a static class, inside a static function, and the type on which you want to extend, you're going to put it, so let me go ahead and add a static function to the program class. I'm going to create a new class over here. I'm sorry guys, I'm extending over time today, but I just want to get done with this first. extension. I'm going to call it extension methods. And the first rule is that this class has to be static itself. The second rule is that the function has to be public, it has to be static, and whatever return type you want to give, you can give that here. And the function name is, I'm going to call it new main. It has to start with this keyword followed by the class that you want to extend, and then you give it whatever name you want, program. And then if you want to accept any parameters here like this, you can get those parameters here. And because it is returning integer, let me return 10, and let's just print this value x over here. Now this new function, it can be accessed using the program object itself. If we go ahead and create that object, I'm going to call new program. I'm going to type obj dot new main. Now new main is a static function that is declared inside a different class using this syntax. What we have essentially done is we have taken a class and we have added a new function which is appearing as if it is the object of that particular, it is already a member of that particular class. And notice the difference in the icon here. The icon here is 3 dots and probably a filled little arrow. So with this arrow, you would know that this is an extension method. And if you hover over it, it is also saying that it is an extension. If I pass it, let me pass 20, and if we comment out this extra code, if I hit Control F5, it is going to print this value CW from the new main function. Alright, so these are extension methods. Now, the collection demo that we are looking at, will be in the interfaces of IEnumerable here, right? So I'm going to copy this interfaces of collection. Alright. Okay, so I pressed the wrong key. So one of the short keys of so Control U short key is going to change everything to small letters, and that's what happened. I'm going to undo, and the run function is we were looking at the where extension method. If you go to where, it is extending the IEnumerable itself. So the three interfaces that we saw, IEnumerable, ICollection, IList, these extension methods, they are all written on the IEnumerable class, right? And they have some nice functionality. Okay, one of the functionality is filtering things out. For filtering, it is going to take a function, and that function is something that we can control from the outside. If we want to select only odd numbers, we are going to write a predicate. We're going to write a predicate that is going to give us a Boolean result. And as long as this Boolean is matching our condition, so I'm okay with, say, this, or if it is divisible by 3. So this thing equal to 0. So now that we have changed the predicate, this where function is going to behave differently. Now it is going to take all the odd numbers, all the even numbers, I'm sorry, and all the numbers that are divisible by 3. And then let's do that. I know that 3 is already present in that list. Let's add 9 as well. Earlier we were only getting square of even numbers. Now we are getting, this is square of 3 and this is square of 9. So depending on how you want to apply a filter, you can influence that thing using using this lambda expression or this delegate, right? So this, and right, let me show you one last function before we call it a day. If you want to generate a range of numbers, there is an extension function available for that, and it is called .range, and it is part of system.collection. Now when you want to generate like 10 or 20 random numbers, I've seen some value over here. So an IEnumerable of integer, if I call the range function, it is going to give me, if I read through the documentation, it is going to say generate a sequence of integral number within a specified range. Right. So what we are doing is IEnumerable of integer. I am not sure how to use that. All right. I'm getting a little confused. I have definitely used this before. It is going to give you uh, 10 random numbers starting from 0. Not sure. Not sure. But then these extension methods, they are available with a lot of options. I'm so sorry. I'm using IEnumerable. I have to use enumerable. Enumerable is a class. If I hit F12, it is going to point to that static class. Right? And now I can do a for each on the range itself and print the item. We go ahead and comment all this code out. And now if I run it, it has generated that sequence. And because it is a collection, once again, you have the option of doing all the where clause and get fancy with the expression. So out of these 10 random numbers, it is only going to give me the numbers whose mod with 5 is 0. And if I do this, it's going to give me 0 and 5. Right? So LinkU is packed with options. Right? There are multiple operations that you can perform, like applying filters, applying selectors, and then you can also go ahead and do the aggregate. Now, an aggregate is going to take a collective result of this particular thing, and it's going to, because it is an aggregate, I'll have to pass two parameters to it, and this aggregate can eventually return you sum of x and y. So with this, we're going to say sum. So it would, the way we had select count star, right? The aggregate is going to do something very similar, a complex syntax, but if I type sum over here and if I run it now, it is going to give me 45. Right? It has added everything and it has given me the aggregate result of that thing. So it is not count star, it is sum star, and it has done an addition in line along with the code. So there are multiple functions available inside this enumerable class. I encourage you to go and read what aggregate is, what all is, what average is, and what count is. Okay, they are going to give you different result on the entire collection. So this is 0 to 9, 0 to 10. Aggregate and any and count, they are going to take different delegate methods over here, perform the operation, and return you the result over here. Alright, so with that, we're going to end our session for today.